In the previous lesson, you were tasked with identifying the joystick positions that would produce each of the movements on this chart. Simple enough, right? All you needed to do was figure out what motor power each wheel needed, and then push the sticks to the corresponding positions. In this lesson, you will learn how to adjust the mapping between the joystick value and motor power to adjust better control of your robot. Let's get some board practice. Drive around the minefield and try to approach mines without knocking them over. It's difficult to make some of the more precise maneuvers. Remember, in the mine retrieval challenge, you will need to pick up the mines without knocking over their trigger stems. We can gain better low-speed control by changing the current mapping to sacrifice high-speed performance in favor of more precise low-speed handling. Let's change things so that the joysticks will map their full range of movement to cover only half of the possible motor speeds. Pressing the stick all the way forward will make the robot move only half speed. We can achieve this by having the robot assign the motors to run at half the value of the joystick input. If the stick is generating a position value of 127, we'll divide that by 2, and the motor will get a power level of only 63. Open your dual joystick control program if it isn't already open. But before making any changes, save it under a new name. File, Save As, Minefield Retrieval. Now, on the lines where the motor power levels are being assigned, change the code so that instead of being directly assigned the joystick values, the motor powers are set to half the joystick value. Divide the VexRT values by 2. Compile and download your program and run it. Now use the joysticks to drive the robot. Notice the difference in the way the robot handles, and see if the change has affected your ability to maneuver precisely at low speeds. The joystick's full range of motion is now mapped out over only half the range of motor speeds. This trade-off gives you more precise control of the robot at low speeds, but at the expense of maximum speed performance. One final note about mappings. While our change was simple, there are many more mappings possible. Some of them are also simple, while others may be more complex and bring additional benefits. Every driver and every robot is different. Feel free to explore these additional possibilities until you find one that makes it easy for you to maneuver the robot.